In this video, we will solve the example problems from 6.34 in vector algebra. Now, what is question? The question says, find the parametric form of vector equation of a straight line passing through the point of intersection of the straight lines. The line is given here, and you have the second line here, and perpendicular to both straight lines. So what is given here is you're given two lines. The first line is given in the parametric form, and the second line is given in the Cartesian form. Now they intersect, so they have a point of intersection, but we need to find the line which passes through this point of intersection and it's perpendicular to both these lines. So first you need to find this point of intersection by equating the coefficients of I cap and j cap and get the point of intersection. Then once you find the point of intersection, find the line which will be perpendicular to both these lines. And our required line can be used as a line which is parallel to this line. So let me just explain the methodology quickly for you. So the methodology would be, kindly bear with me, just if you understand the methodology, then you can do it so easily. So first, we're going to take this equation 1 and convert it into a Cartesian form. So to convert it into Cartesian form, this is our point through which the line passes through, and this is the parallel line. So we can use 2, 3 and 2 as our DRs, and this as the coefficients of I cap, j cap and k cap as x, y and z. So our Cartesian equation would be x minus coefficient of I cap is 1. So this will be x1, y1 and z1 divided by the dr, which is 2 equals y minus 3 by 3, the direction ratio, then z plus, it's minus 1 here, so plus 1 divided by the direction ratio 2. We can call this as equal to s. Similarly, we can call this as equal to t. Now solving these two equations, you will be able to rearrange this. Let's say x minus 1 by 2 is equal to s, which implies that x is equal to 2s plus 1. Similarly, we can write y is equal to, if you move the 3 to the other side, so it will be 3s plus 3. Similarly, z plus 1 by 2 is equal to s, so z will become 2s minus 1. Similarly, rearranging this, you will get x is equal to t plus 2, and you will get y is equal to 2t plus 4, and z is equal to 4t minus 3. Now, if we solve these two, rather, if we equate the values of x, y and z, because that's the point at which they are intersecting. So we can say that t plus 2 is equal to 2s plus 1 from here. Similarly, equating what is the y value, we can say 2t plus 4 is equal to 3s plus 3. Similarly, we can say 4t minus 3 is equal to 2s minus 1. Okay. So what we did is we found the Cartesian form of the equation, then we have rewritten them in this form and found the values of x, y and z where the point will intersect, and we have got these three lines. So if we solve these three lines, we will find the answer. I'm not going to solve this now. We will solve it, as we do the actual sum. I just want to give you an overview of this, so it's easy for you to do the problem. And once you have found these values, then substituting these values into the values of x, y and z, you will find x is equal to, say, 2s plus 1, so that is going to be 3, and y will be equal to 6 and z will be equal to 1. So your x, y and z is 3, 6 and 1. Okay. Now we have found the point through which our line passes through, the required line. Okay. Now we need to find the line which is parallel to the required line. So now we know the required line is perpendicular to these two lines. So let's find the lines which are parallel to these two lines. So here we can say that this is parallel to the line 1. So let's say that vector B, which is equal to 2i cap plus 3j cap plus 2k cap, is parallel to line 1. Okay, this is line 1 and this is line 2. And vector D will be, these are the direction ratios, so we can use them and we can form the vector equation, and that will be the vector that is parallel to this line. So that is I cap plus 2j cap plus 4k cap. So that's the line parallel. Okay, now we have found these two lines which are parallel to L1 and L2, but we need the line which is perpendicular. We know that B cross product with D will be perpendicular to both B and D, right? So if B cross product with D is perpendicular to both B and D, then B cross product with D will be perpendicular to line 1 and line 2. So B cross product with D is parallel to the required line, and our point 3, 6, 1 is a point. So we will find the value of B cross product with D, then we can write our required equation as this is our point. So 3 I cap plus 6 j cap plus k cap, plus we can use a scalar m multiplied by the cross product of B and D. This will be the required line. So it's just to give you an overview of what we're going to do. Now let's actually solve the problem. Okay, now let's go ahead and solve the problem. So you have the Cartesian equations of the first equation as this. We have already seen how to work that out. Okay, using the direction ratios of 2, 3 and 2 here as the denominator, and the 0.13 minus 1 as our x1, y1 and z1. So we have this equals to s. Similarly, we say the second equation is equal to, t. Now our x is equal to 2s plus 1 here, and our y is equal to 3s plus 3, and our z is equal to 2s minus 1. Similarly, here our x is in the second equation, x is equal to t plus 1, y is equal to 2t plus 4, z is equal to 4t minus 3. Now equating these two lines, points, we can get our s as 1 and t as 1. Alright, then if we substitute the values of s and t into these points here, or even these points here, then you get your points as 3, 6 and 1. Alright, so now that we have these points, now let's define the vector B and vector D. So vector B is parallel to the line 1 and vector D is parallel to the line 2. So B cross product with D is the determinant of this matrix. So this, I'm sure that you're familiar with this method. So this gives you the 8i cap plus minus 6j cap plus k cap as your resultant vector, which is B cross D vector. So required line passes through 3, 6, 1 and it is parallel to 8i cap minus 6j cap plus k cap. So substituting, you will find that our vector R is equal to 3i cap, which is, you take from this points, 6j cap plus k cap, plus m times, m is a scalar quantity which belongs to R, multiplied by our b cross d vector, which is 8i cap minus 6j cap plus k cap.
Thank you for watching Maths Tutorial Anand. Please like and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.